Welcome you all. Now we are going to solve the engineering mechanics questions asked in the GATE 2024 mechanical engineering paper. First question. A rigid massless tetrahedron is placed such that vertex O is at the origin and the other three vertices A, B and C lie on the coordinate axis as shown in the figure. There are three forces acting. One force is acting at A along x-axis, another force at B along y-axis. For the object to be in equilibrium, the third force is dash. So where we have to apply the third force? See, one force is applied here, another force is applied here. Right. Then where we have to apply the third force? So the condition is we have to satisfy the equilibrium. Right. So if you apply the third force in the z-axis direction, right, so you can satisfy the concurrent system. It means moment equilibrium equation will be satisfied, but force equilibrium cannot be satisfied. So what we have to do? So we have to apply the force in the xy plane itself. Like this. If I apply the force like this in the xy plane, right, so I can satisfy summation of fx equal to 0, summation of fy equal to 0, summation of mz equal to 0. Okay, right. So what is the option? We have to apply the force in xy plane but not along x or y axis. Option C. Next question. A ram in the form of rectangular body 9 meter cross 2 meter is suspended by two parallel ropes of length 7 meter. Center of mass is at the geometric center. G is given. For striking the object P with the horizontal velocity V equal to 5 meter per second, what is the angle with which vertical object should be released from rest? So released from rest, it means initial velocity 0. Okay. So let us assume here initial velocity 0. So initial kinetic energy Ke1 equal to 0. Okay, right. What is the kinetic energy in this point? In this point, Ke2 equal to half mv square. V is given. Okay, how much? 5 meter per second. Now how we are getting this energy? Sir, at the cost of potential energy. So potential energy is reduced, kinetic energy is increased. So what is the initial potential energy? Right. mgh Pe1 is equal to mgh. Right. So where is H, sir? Sir, this is your H. Okay, right. Height between initial and final states. Okay. Now, how to write the H value? Right. Let us say this is 7 meter is L length. Okay, right. Then this portion will be 7 cos theta. Okay, right. Then what is H value? Equal to 7 into 1 minus cos theta. 7 minus 7 cos theta. Okay, right. That's all. Right. Then what is the final potential energy? 0, sir, datum. So we know the initial kinetic energy, initial potential energy, final kinetic energy, final potential energy. So we can go for law of conservation of energy. P1 plus KE1 is equal to PE2 plus KE2. Here 1 and 2 are initial and final states. Initial potential energy mgh, mgh is equal to 7 into 1 minus cos theta. Then kinetic energy 0 equal to final potential energy 0 plus half into m into v is 5 square. Okay, right. So g is given 9.81. We can substitute. So m will be cancelled. Okay, right. So by solving this, only one unknown is there, theta. Okay, right. So by solving this, theta is equal to 35.1 degree. Directly we can get it. Okay, right. Next question. 2 more question. A 3-inch